my YouTube channel. In this video, I'm going to show you on this will be the third part of the last part of Form 5 Chapter 2, Electricity, where in this video I'm going to talk about parallel and series circuit, and followed by power rating. Now to start out with, what is parallel circuit? Okay, now parallel circuit is, well, you have a battery. One is called cell, a pair of it is called cell. Combination of cell, it will be a battery. Okay, and also the next video I'm going to show you on the electromotive force, EMF. Okay, before we get to that, let me show you on parallel circuit, where whenever we talk about parallel circuit, then they are going to have two different load. It will be a resistor for our discussion. Okay, I missed out another one. Okay, where you can see from here, the current goes out from the positive terminal and then get into the negative terminal. That's where the direction of the current. An electron would be from the negative terminal out into positive. For the sake of our discussion today, I will be using the current. Okay, current. So current goes out from the positive. Then once it comes to a junction, once it's reached a junction here, okay, what happened? The current splits. Well, in the event when the resistor is similar, meaning R1, R2 is the same, if they are the same, what happened? The current will be split into, I1 and I2. Okay, so in the event that I1 and I2 is the same, so therefore the current of I1 and I2 will be the same, meaning it will split half from the I. Okay, this is the characteristic for parallel series. For parallel circuit, where the I total is actually equals to I1 plus I2 because it's split. Okay, whenever it comes to junction, it's split. Alright, so another characteristic, this is the first characteristic, the current split. Okay, secondly, from what we have learned in our previous video, I don't want to show you, in Ohm's law, we talk about V equals to IR. Okay, V equals to IR, we talk about this in my previous video. So I'm going to use that. Now, here, which is equals to V equals to IR, so therefore V1 is actually V over R1 plus V over R2. That will be our second characteristic or condition, where my current is equals to, is a constant, V 1 over R1 plus 1 over R2. Now there are a few things to talk about. Here, our voltage is the same, meaning the voltage here and here is the same, because what is voltage? Potential difference is actually work done per unit charge. So the potential difference at this point and this point will be the same as with this point to with this point for parallel circuit. And then the parallel circuit, the voltage here, voltage across these 2 points, same as with this 2 point and this 2 point, because they are parallel. Okay, so this is the second characteristic, whereby the voltage is the same for the two load. Okay, then the third characteristic for a parallel circuit would be from here, okay? But V equals to IR. So what happened? Here, your 1 over R total is therefore be equals to 1 over R1 plus 1 over R2. Okay, how is that so? Because previously also from Ohm's law with V equals to IR. Okay, so if you were to have V over I, or I over V, I mean you bring this down, I over V, therefore it's actually equals to R. Okay, or the other way, without confusing you, okay, the R total for a parallel circuit, this is how you relate it. 1 over R1 equals to 1 over R2 plus 1 over R3. Or the other way around, to talk about RT itself, this is called the it's effective resistance, okay, in your reference or text. R1 RT is effective resistance. Okay, what does it mean? It means if you reach up to here, if you manage to get RT in some objective question, you may be able to simplify the circuit into this form, where you have your battery, okay, and the RT is a combination of the two. You may regard it as here. Then you're able to calculate what is the current and what's the voltage, etc. So one way, one rule, the thumbs up rule to solve this kind of question is you get the effective resistance. Okay, then what we will do next would be is it possible to find out, okay, if you were told of the source, and will you be able also the resistance I1, R1, R2, will you be able to tell what is the I1? Okay, so I'm going to do that. Excuse me. Now, since from our previous discussion, V equals to IR, Ohm's law, so here I is actually direct and inverse proportional to R. Okay? Excuse me. Now, from our previous circuit diagram, I1 and I2, since they are inverse proportional, so therefore inverse proportional, so my I1 to I2 ratio would therefore be equals to R2 over R1, because they are inverse proportional, right? Then if you want to find out what's I1, so I1 would therefore be R2 over R1 times I2. Okay, but since from our first condition, this is a combination, it's junction, isn't it? I1 is total current, subtract I2, bring it over. So therefore, you substitute that to here, I2. Therefore, your I1 would be equals to R1 over R2 plus 1 I mean, you simplify I2, of course, times I. Change it back to here, times I. Because I2 is basically I minus I1. Okay? You substitute this into here. You should be able to get this result. Okay? Then you simplify further. Therefore, your I1 will be equals to R2 over R1 plus R2 times total current. So the moral value of the story, if you want to find out what is this current I1 in some objective question, this is how you do it. You're going to find out what is I1. You use the R2 value, the opposite value, because it's inverse proportional. Use R2 over the sum of resistance. You times with the total input of your current. Right? So this is for the parallel circuit. Okay. Okay. Now from here to here, I've simplified the equation. That's why you can't see it, because later if you you substitute this I2 into this equation, you have a value of I1. Then you need to rearrange them so that you have I1 over left hand side, and then this is the result. You may pause this video and you try to substitute this into the equation, and I'm sure you can do it because it's a basic mathematics. You take some time, of course, for arrangement before you go to our next segment. We have series circuit. Okay. For series circuit, it would be cell, battery. They are in the same line. Okay, this is your potential difference, where my circuit flow out from the positive current. Gain of I1, this is R2. Now what happened to series circuit? Here, when current goes in here, it doesn't split anymore, because the amount of current goes in will be the same as the amount the current goes out. And the same goes with, it goes into R2 and then it goes out from R1. So therefore, the current passed through R1 and R2 will be the same, because current relates to electron. So the number of electrons that pass through R1, R2 is the same. So here, the first characteristic, the current into and out is the same. Okay? Alright? The one goes in, same as the one comes out. For series circuit. Here they're the same, because there's no way to branch out. It doesn't split out. Okay? So therefore, your V1 and V2 will not be the same anymore. How is that so? Which will be our second characteristic. In series circuit, your V total, the V potential over here, is equal to the sum V1 plus V2. Because it's all about the work done to bring a charge from one side to another. So from here, let's say for example, initially you have 100 joule goes in. So work done, you use up 50, maybe 40 joule over here. Then you left with another 60 joules comes here. So you only have 60 joule to push an electron from this one to this point to this point via R2. So the total potential difference is actually the sum of the individual potential at the resistor. So because of that, therefore your V total would be equals to V equals IR. I is the same, R1 plus I is the same for 2 R2. So therefore your V total is actually equals to the factorize them, R1 plus R2. And this is what it meant by effective resistance. Okay? Where your R total is R1 plus R2. Meaning, if you want to simplify this diagram, if you want to look for a solution, look for the current or look for any other circuit, you need to simplify the circuit into, first step would be to simplify it into a resistive resistance. If you doesn't know how to start, don't know what to do, you start out with getting the effective resistance. That's the best way to do it. Okay, so for series circuit, we are talking about here we are talking about series, yeah, in series. In series, V is direct proportional to R because the I is the same, right? I is the same for all resistor. Okay, so therefore, your I is therefore equals to V1 over R1, which is also equals to V2 over R2. Put them into simpler form, V1 over R1 is equals to V2 over R2. It's a rewrite from here. Let's focus at this part. So again, if you want to look for voltage at one resistor, so you rearrange this equation. So therefore, your V1 is actually equals to, you group them the resistor R1 over R2 times V2. Same trick work here. Your V1 would therefore be equals to R1 over R2, where V2 is actually the V total subtract V1, having in mind V is V1 plus V2. So you bring it over, then this, you rearrange it, times it in, V1, you group them over the left, and then rearrange, factorize, rearrangement, then what you will get, your V1 supposed to be R1 over R1 plus R2 times V total voltage. Okay, make use of this equation. It helps you to solve objective question under 2 minutes. This is what they use. Okay, this is what you should use to solve objective question. You don't need to find out individual current so long until that's why people can't finish the objective question. Why they can't finish? Because they don't want to use this equation. For series circuit, it's direct proportional. So V1 equals to R1. You mix with R1. V1 R1 over the total times V. Okay, that's the first equation you should know. Whereas for parallel circuit, something different. Special is the current, right? The current split. So the current inverse proportional to R. So therefore, your instead of I1 here, you use R2, the opposite resistor, because it's R2 over total times I. Okay, this is the equation that you should know for parallel circuit. In addition to, I mean, those are the one that you know already by now, right? I mean, here, this one, second one, and the parallel circuit. This is the effective resistance. I would personally advise you to pause this video, go through your chapter by chapter exercise on parallel and series. You should at least try about 15 to 20 objective questions. Okay, in a week time, of course, it's not a day, so that you really get the essence out from here. All right. Then I think I will stop here, and my next video will be on power rating and EMF, electromotive force, so that you can really concentrate at parallel circuit, because it's quite important in SPM. You will have at least 2-3 questions comes out. Okay, I hope in a week time, next week, before I come back for my next video, next week, you have at least tried 20 questions for parallel series, objective question. You do it on yourself, check with the answer. Okay, I really like those thumbs up button. Kindly press on those thumbs up button. It encourages me a lot. It doesn't cost you anything, it's free. And do subscribe to my channel if you haven't done it already so. Stay tuned to my next video.